So now we're going to talk about what happens when we take one of these conic sections and actually shift it around the coordinate plane. That's why this is section 11.4, shifted conics. So we'll be starting with parabolas. And what you see in terms of vertical axis and horizontal axis are very similar formulas to what we saw back in the first section of this chapter. But notice that within the squared portion, there is a minus and then a letter there, H or K. And then similarly with the variable on the right-hand side, also K or H. And what that is simply the vertex. So for the parabola, that's the new vertex. When you can write it in this form, you can find the vertex. The directrix, remember that's that line, vertical or horizontal. And that can be found simply by, in this example, doing K minus P. And I'll show you what an example looks like in just a moment, H minus P. So it comes from just taking one of the coordinates of the vertex and adding or subtracting that P to get us, actually the focus and the directrix can be found using that P and your vertex. So just a slight difference. Let's take a look at an example and hopefully that'll clear it all up. So we have an example here. Our job is to find focus, directrix, and graph. So that means we need to write it in that form that we saw. In this case, we have the y squared. So it'll be y minus k squared, and then 4p x minus h. So that's our goal, is to first write this in that form. So it's going to involve completing the square. So we've done that before. It's coming back. Make sure you know how to complete a square. What I'm going to do is I'm going to start out by putting anything with a y on one side. If it doesn't have a y in it, then I'm going to move it to the other side. And the reason I'm doing that is because I want to be able to get that y squared as my complete square. Then, of course, we're going to add something. That's the whole idea behind complete the square. So think about what value we are going to need to add so that that is a complete square. Hopefully you are thinking 9. If you are correct. We're going to do that to both sides. Again, we're just trying to, our goal here is to write this in this form. So now we need to rewrite our complete square that we have on the left-hand side. So it can be factored into something squared. Take a second, see if you can think about what that is. We've got y plus 3. And over on the other side, we have 3x minus 3. Now, if we want to truly write it in the other form, notice we'll have y minus a negative 3. And on the other side, we'll have 3x minus 1. And now it is truly in the form that we see up in the corner and that you have above. So from this, we know a lot about our parabola. We know the vertex. The vertex is HK, where, as you can see, H is with the X and K is with the Y. So we know our vertex is 1, negative 3. So we just go ahead and put that on. Okay. And in order to then graph this, we could think about the fact that our P is positive. So P equals, in this case, P equals 3. 3 is greater than 0. So that means that our parabola is going to open to the right. Open to the right. And that's simply because, you can see what we have there. If P is negative, then it would open to the left. But our P is positive, so it opens to the right. In the other version with the vertical parabolas, if P is positive, it's going to open up. If P is negative, it'll open down. So, remember those things? Okay, so we have our vertex, we have P, and So another thing we should find is to find P. Let's remember that whatever your constant is in the front there, that's going to be equal to the value that you have when we factored the right-hand side. So it tells us that our P is equal to 3/4. So since P is positive, so P is greater than 0, so that means our parabola is going to open in that positive direction. It's going to open to the right. Notice this is a y squared that we have, so that tells us it's one of the horizontal parabolas. So opens to the right. Okay, so we have that. And then, like it says above, the idea here is this 3/4 helps us do the focus and the directrix. So our directrix, if you take a look at the notes there, because it's a y squared parabola, our directrix is x. It's a vertical line. It's h minus p. And so it's just, p units to the right of the vertex. So this is our directrix here. And then our focus is just, wow. And then our focus is just that P to the right of our vertex. So somewhere right here. So if you want, you can think of the focus. The focus is simply taking your x value for h, which is 1, and adding 3/4. And then the y is the same as the vertex. That doesn't change. So it's basically 7/4 -3 for the focus, if you want to have that. That is helpful because if you know the focal diameter, so we can find that. Focal diameter is still the same. That doesn't change. So it's the absolute value of 4 times p. And that gives us 3, which is exciting and easy. And so that just means that we want to go 1.5 up from the focus and 1.5 down from the focus, so vertically. And so we'll go 1.5 here and 1.5 here. And so that allows us now really to graph this parabola now that we have all this information. So we're going to go like this. We know the shape of a parabola, so we just go ahead and connect it. Don't like that, so get rid of that. There we go. And come around. Oh, okay, I almost hit it. Anyway, then we have our parabola. So notice it's very similar. It's really just a shift. So once the vertex is set, everything else that we've done so far comes back into play. It allows us, as you can see, to graph our parabola just on a different part of the coordinate plane. Okay, now we have an ellipse, and I want you to notice that the only thing that is different is the center. So it makes doing the ellipse fairly straightforward because you just have to know where the center is, and then you can use your A and your B to find from the center how far are we going vertically and how far are we going horizontally for the ellipse. So it is fairly straightforward. You do have a note there that I've covered just due to spacing. And so notice it's like main thing is to find the center. The center is now HK, and that is now your new origin, and you're just using the vertical and horizontal pieces from A and B to get the rest of the ellipse. So you should see for this example, what is the center? Notice that we do have the subtraction signs. You don't want to forget that those exist, so that if you want to, you can see this is y minus a -1 squared. So that gives us 2, -1 for the center of our ellipse. that is not actually on the ellipse. Do you remember that? It's not on the ellipse, but it is the center. We can see that A and B, take a look, think about what our A and B are here. So A is 2, B is 3. And the A is where we're going in the X direction, and the B is where we're going in the Y direction. So now we know that we need to go horizontal 2 units and vertical 3 units. And that's going to give us the height and width of our ellipse. So horizontally 2 units will take me here and take me here. And vertically 3 will take me up here and down here. And since we know we have an ellipse, and we want to be able to recognize it ourselves here, so we do have addition in between, we have an x squared, we have a y squared, so that's really what's telling us that we have that ellipse. Now we can combine all the outer vertices here that we found, and we've got a pretty good, I'd say, ellipse, except for that side. Maybe that's because I'm left-handed, but that looks a little wonky. But yeah, that's all that it is for the ellipse. Find the center, and then use your A and your B under the x squared portion and the y squared portion to figure out how wide the ellipse is vertically and horizontally.